Welcome to The Explainer. Today, we're treating the construction of the Great Pyramid not as some mystical legend, but as a thrilling, forensic cold case. We're going to explore the architectural marvels of the Giza Plateau and really focus on the real secrets behind the engineering techniques used to build this unbelievable structure. The sheer logistical nightmare of this project is just extraordinary. And as you'll see, figuring out how they did it reveals some of the most sophisticated visualization and planning in human history. So let's dive right into the question that has literally baffled humanity for millennia. How on earth did early Egyptians level the site and position enormous blocks of limestone and granite, we're talking stones weighing up to 20 tons here, to create a monument with such precise dimensions? Remember, they only had basic copper tools like saws and chisels. They understood levers and inclined ramps, sure, but they completely lacked modern machinery, wheels, or pulleys. So how did they actually pull this off? Well, right off the bat, we have to politely dispel some of the wilder myths out there. Take those Victorian theories adopted by Chris Dunn, for example, claiming the pyramid was some hyper-precise laser machine. Some theorists even go as far as to suggest that hydrogen gas was pumped into the subterranean chambers to create a vibrating proton energy beam. The problem with that? There is absolutely zero evidence that the Egyptians had hydrogen gas. No impermeable containers for it have ever been found. And as for the lasers, yeah, there aren't any holes to actually hold them. To bring us firmly out of science fiction and back into reality, all we have to do is look at the historical survey data. Back in 1880, Sir W. M. Flinders Petrie conducted the first truly scientific excavations on the Giza Plateau, and modern experts like Zahi Hawass will tell you Petrie's measurements were incredibly accurate. In fact, Petrie found a 75-inch orientation discrepancy between the core and casing stones. Now, don't get me wrong, it's still an absolutely massive achievement for the time, but that 75-inch gap shows natural human error. It completely debunks the myth of some fabulous, alien-like precision. Okay, so bringing it back to human engineering, here is the ultimate challenge they faced. Workers had to place an estimated 2 million to 2.5 million stone blocks, and these blocks weighed an average of 2.5 tons each. During the first years of construction under Pharaoh Khufu, the builders had to set these massive stones into place at a staggering rate of 5 every single minute. Just think about that for a second. 5 massive stones every single minute. And to really wrap our heads around the sheer scale of that challenge, let's look at the volume. Originally standing at 481 feet high, the Great Pyramid incorporates about 3.4 million cubic yards of material. To put that into a modern perspective, that's roughly 2/3 the volume of the Hoover Dam. And again, they managed the whole shebang without a single piece of heavy modern machinery. Let's examine our first suspect for how they did it, the traditional long ramp model. Historically, a lot of scholars believed builders just used a single, massive ramp on one face of the pyramid. But there's a huge physical limitation here. If a ramp slope is more than about 8%, or 8 to 12 degrees, workers literally cannot drag stones up the incline. It's just too steep. So to keep a usable slope all the way to that 481-foot peak, a single ramp would have needed to be over 1 mile long. But when you map the Giza Plateau, you instantly run into a massive geographical problem. There simply wasn't room for a mile-long ramp. You'd end up burying nearby cemeteries or just falling right off the steep slopes. While the pyramid was going up, they were simultaneously building 2 nobility cemeteries on the east and west sides. The north side has a steep drop-off. That only leaves the south side, but we've never found any remains of a massive ramp there. Plus, a mile-long ramp would require almost as much building material as the pyramid itself. It just doesn't make sense. So, with the straight ramp totally ruled out, researchers naturally shifted their focus to an exterior spiral ramp model. This design basically wraps around the outside of the pyramid as it goes up. At first glance, it's great. It perfectly solves the whole mile-long space issue, and it explains why we haven't found giant ramp ruins stretching out into the desert. But it introduces a fatal engineering flaw for the workers. Here's the crucial point. Workers pulling those sleds would have absolutely zero leverage to safely maneuver a 2.5-ton block around sharp, exposed 90-degree corners. Imagine trying to pivot a car on a narrow ledge hundreds of feet in the air without tipping over the edge. No way, right? It's an insurmountable design flaw. It makes the exterior spiral ramp highly unlikely to be the primary method for the upper levels. And this insurmountable flaw brings us to a really brilliant modern plot twist. In 2003, French architect Jean-Pierre Houdin used 3D architectural software from Dassault Systèmes to evaluate these different ramp models. He came up with a groundbreaking hybrid theory. His model suggests the builders actually used a smaller external ramp for just the bottom third of the pyramid. Then, they dismantled that external ramp and used its blocks to build the rest of the pyramid using a hidden, corkscrewing internal ramp. You might be wondering, though, how did they solve the corner problem inside the pyramid? Well, inside this enclosed ramp, Khufu's architect Himyinu left open spaces at the corners. In these open, L-shaped rooms, workers likely used wooden cranes based on the shaduf. That's a traditional device the Egyptians used for lifting water out of the Nile. By setting up these cranes in the corners, they could easily and much more safely lift and rotate the stones 90 degrees to head up the next leg of the spiral. And guys, here is our smoking gun. Back in 1986, a French surveying team used microgravitometry to check the density of the pyramid. They were basically measuring tiny variations in gravity to find hollow spaces. Their scans revealed a distinct image, a lower density spiral running right parallel to the outer faces. For years, nobody fully understood this anomaly, but when you pair it with Houdin's theory, it perfectly maps out an internal ramp. Even better, there's a physical, visible notch right on the northeast corner of the pyramid that aligns exactly with where one of those L-shaped crane rooms would be. This genius internal ramp theory so neatly explains the total absence of massive ramp ruins on the plateau today. If that exterior ramp used for the bottom third was meticulously taken apart, and those smaller limestone blocks were carried up the internal ramp to finish the top two-thirds, the evidence of the construction was essentially consumed by the pyramid itself. And there's more. The existence of an internal ramp at the nearby Abu Ghurab Sun Temple, which was built by Pharaoh Nusere about a century after the Great Pyramid, proves this exact construction technique was already right there in the ancient Egyptian playbook. It optimized materials, it minimized excess labor, and it perfectly solved the tight spatial constraints of the Giza Plateau. It's truly fascinating to see how generations of detectives have pieced this giant puzzle together, isn't it? We go from Flinders Petrie's meticulous 1880 tape measures to the 1986 microgravimetric density scans, all the way to Jean-Pierre Houdin's 21st century 3D modeling. But figuring out how the stones went up, well, that's really only half the battle. Because solving the lift begs another massive question about ancient logistics and program management. How did they actually marshal these vast amounts of materials from all over the Egyptian kingdom and then deliver them to the Giza Plateau fast enough to feed a construction rate of 5 blocks a minute? The astonishing answer comes from a literal ancient diary. It's part of the Wadi al-Jarf papyri, written by an official named Inspector Mir. In it, he actually describes his men approaching the plateau with boats full of limestone blocks, and he explicitly mentions passing through a waterway called the mouth of the Lake of Khufu. As modern Egyptologist Mark Lenner confirms, Khufu's master plan was way more complex than just building a pyramid in the sand. His project included this huge, extensive network of artificial basins and waterways. This ingenious maritime infrastructure meant heavily laden boats could float right up and deposit their heavy stone cargo directly at the edge of the plateau. Modern topographical mapping of Giza reveals something incredible. The entire layout in the 4th dynasty wasn't just a basic building site. It was a highly managed megaport. It was this sprawling complex featuring workshops, bakeries, and water channels, all explicitly designed for peak logistical efficiency. They had to ensure those stones never, ever stopped flowing to the builders. So what we should really take away from this explainer is that we don't need to invent fictional power plants or invisible proton beams to be amazed by the Great Pyramid. The real magic is in supreme human organization, program management, and sheer resourcefulness. From artificial harbor networks to hidden internal corkscrew ramps and corner cranes, the sophisticated visualization required by these ancient Egyptian architects is the true ancient wonder. Right now, researchers are waiting for approval from the Supreme Council of Antiquities to conduct new, non-destructive thermal imaging on the pyramid. If Houdin's internal ramp is still actually in there, these thermal photographs should clearly show pockets of cool air trapped between the hot stones. And honestly, it leaves us wondering, as modern technology finally catches up to ancient genius, what other brilliant architectural secrets are still sealed inside those walls, just waiting to be uncovered?